Okay, guys, we're going to do a acceleration calculation, and this will be your number one TOC for the green table of contents, the new table of contents that will start tomorrow. I will erase the orange one this afternoon. So these are going to be the notes, the very first TOC. The notes will be named acceleration calculation. Here's our problem. A car speeds up to 100 meters per second from rest. It does so in 4 seconds. What is its acceleration? I have circled the question so that we know that we are solving for acceleration and that we must have a formula that is set equal to acceleration. And that formula for acceleration is v2 minus v1 over t, where A stands for acceleration, V2 stands for the second velocity in the story, and we're going to talk about that in just a second. V1 stands for the first velocity in the story, and T obviously stands for time. All right? So now as we read this, I want us to focus on the story here. A car speeds up to 100 meters per second from rest. So what that's telling me is that the car was initially, the first velocity was 0 meters per second because that's where it started. It was at rest. So in the story, as you're reading the story, and we imagine the story in our minds, then the very first thing the car was doing was stopped, and then it sped up to 100 meters per second. So that means then, as I list out my pieces of the equation over here, that the first velocity in the story, not necessarily as I read it in a sentence, but in the story, as I imagine the story, the first velocity was 0 meters per second. And that means the second velocity is how much? That's right, 100 meters per second. I'm trying to find the acceleration because that was the question that was asked me. And the time that it took for it to speed up from 0 to 100 meters per second is, that's right, 4 seconds. Great. All right, so now I can just plug all of this in, all of this stuff into our formula over here, and I wind up with a question mark equals V2. V2 is 100 meters per second. Do not forget the units. V1 goes into V1 minus 0 meters per second. All of this is over, right, because it's a fraction, over the time. And the time here is 4 seconds. 4 seconds. So that when I do my math, then 100 minus 0 is 100 meters per second divided by 4 seconds. And when I complete that math, 100 divided by 4 is, that's right, 25. And my units now are meters per second, or 25 meters per second squared. And acceleration will always have a square in it, in the bottom time. Acceleration always has a square in it. It will always have a square in the time. All right, so the answer to this question then is 25 meters per second squared. That means every second that went by, it sped up 25 meters per second. Now let's look at this picture for a second. I want us to, let's create us a new little flip chart here. And so the car started out at 0 meters per second. At time 0, it was 0 meters per second. After 1 second, how fast was it going? If we said that it sped up 25 meters per second every second, 25 meters per second, or 25, we can also say 25 meters per second squared. After 1 second, how fast was it going? That's right, 25 meters per second. After 2 seconds, it was doing how fast? Was going how fast? Yes, it sped up another 25 meters per second. So when we add those together, it's 50 meters per second. After 3 seconds, it was doing, that's right, 75 meters per second. And after 4 seconds, which was how long the problem had, if you remember, let's look at the problem. The problem was, I'm trying to find it. Where's it at? Where's my problem? Hello? There it is. The problem says it does so in 4 seconds. Amen? So, 4 seconds right here. After 4 seconds, it was doing 100 meters per second. And so that's what the problem tells us it did. It went from 0 to 100 meters per second in 4 seconds. So that means every second then it did 25 meters per second. You're awesome. Have a great day.